All right, so this is the review for the 9.5 to 9.7 quiz that we'll go through. Okay, so starting with the first one, in order to do the first few, it'll help if you have the list of perfect squares. So I'll go ahead and just write them at the top here in case you want to find them. Remember, you're just taking each number and squaring it. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So I'll go to like maybe 100, but you can write it down if it would help you. So this is 4, 5, 6, 7 is 49. Then we have 64, 81, and then 100. But of course, we could keep going. That's just to kind of give us a head start. So like that first one, you see 36 inside that radical. We see a 36 right here. We know that that's a perfect square, so that we could just pull it out. And so remember, the rule with these even exponents inside the radical is you can just cut the exponent in half when you take it out. But you can't leave odd ones. You can't do the same with odd ones. So let's first rewrite this as square root of 36. Then I'll leave it x to the 6th, though I did show you a longer way to do this in class if you wanted to write them out first as x squareds and then do it. It would just be, you could do it that way, but it would just take a little bit more to write out. And then we have y squared and just a y, because I'm splitting the cubed into that because it's easiest to deal with even exponents, cutting them in half. So this would be 6x cubed, because I'm taking the 6, I'm cutting in half. Half of 6 is 3 when you take it out of the radical. Then we have a y just by its own, because the squared and the square root, again, you could cut the squared in half. That's just going to be a 1. And then finally, square root of y stays inside the radical. That is as far as you can simplify it. We'll do the same thing for number 2. This one is already, like, I don't need to like rewrite this at all because I can just take the square root of 9. Well, if you want to split them up like this, you can, though you don't have to. You can just go right to taking out what you can out of the radical. So square root of 9 is another perfect square. It is 9. I'm sorry, 3 when you take the square root of it. Then we have x squared, because the square root of the 4 inside there will just get cut in half. But then the square root of y just has to kind of hang out while still in that radical. Cannot take that out because it's not even. Only even roots get cut in half as they come out of the radical. The odd ones, for example, the 1 has to stay in. Now, if it was like y cubed, like this one, split it up into an even and an odd, and then keep going. All right, so that's how we simplify. Now we're moving on to, we're still kind of simplifying, but now we're going to add and subtract radicals as well. First thing you need to do is think of all your, again, use these perfect squares to help you as you try to simplify these radicals. Always think of what's the largest perfect square that can go into each of these numbers. So for 18, that would be 9 times 2. The square root of 9 is a perfect square there, or 9 is a perfect square. So I'll write that as square root 9 and then square root of 2. I can either put the x with the 2 or just on its own like this. Keep going. Now we have a plus 8. First 27, I would have a 9 and a 3, and then just an x, because the 27 has a perfect square in it, which is 9. Then we have a minus 7. And then for 12, the perfect square sitting inside 12 is 4. So we would have square root of 4, and then 4 times 3 with just the x. So that's how I would start. And now from here, we're going to kind of simplify further. So square root of 9 we know is 3. Then the 2 and the x you want to combine into its own, into one radical. Same thing for the next one. We have an 8 times square root of 9 is 3, and then again combine the 3 and the x. 7 times, or then the next one is a minus 7 times 2, because the square root of 4 is 2, and then again you have 3x. So we're almost there. You can always do this multiplication. You don't have to write it down each time. If you want to just simplify it kind of in your head, that's fine. This would be 3 root 2x plus 24 root 3x minus 14 root 3x. And when I see that, I see the 3x's here, which I'll highlight so I can show you. These are the same. The 2x obviously is not. So the ones that we can combine are only the 3x's. 24 minus 14 is 10. So we would get 10 root 3x, but then this 3 root 2x is still going to stay there. Kind of just bring it straight down, bring down the plus sign, of course, to in between the two terms, but that's how we get to our final, I'm sorry, I wrote, nope, that's right. Yep, that's how we would write our final answer, just like this. So that we could not combine the 2x and the 3x any further, we would leave it just like this. All right, let's try number 4. Same idea, but we have 20 this time. So we have -2 still sits there, but then we can do 4 and 5 are the two factors for 20, where one of them is a perfect square. Then we have a 2, then we'll do 9 and 5. And then finally, that last 5 on its own inside the radical just kind of has to stay square root of 5 on its own there. All right, so from here, I'm going to start simplifying a little bit more. If you want to do this kind of in your head, where you could say -2 times 2 is -4, you could jump right to the next step. I'll go ahead and write it down for those of you that need it, but you could, of course, skip this step if you wanted to just do this part in your head. So all I'm doing is just simplifying each of those perfect squares inside the radicals. And so now we have -4 root 5 plus 6 root 5 plus root 5. Now, if there's no number in front of the radical, you can put a little 1 as a placeholder, because that's what it's saying, that there is one of these root 5s. So now that they're all square root 5, that's good. The other one was not like this, but now this time they are all square root of 5s. I want to combine all the numbers in front. -4 plus 6 would be 2, plus 1 is 3 root 5. That's the final answer. So it can simplify pretty, you can go all the way down until you just get to just that much. All right, let's try the next one. Okay, so number 5, we have square root of 18x plus 90. And we are, again, simplifying this. So the first thing you want to start with is ask yourself, is there a GCF? Now, it doesn't have to necessarily be the greatest common factor that's common to both, but it has to be a perfect square. So if I think of 18 and list like some of the factors, I know that I have 1 and 18, 2 and 9, and 3, no, yeah, 3 and 6, and then that's it. But if I look at my list here, I don't have very many perfect squares. I only have the 9. So no matter how many factors 90 has, as long as it just has obviously a 9, I can factor the 9 out. So that's my GCF that I want to factor out of these. Even if it's not the biggest term that goes into both, I know that that's the only one that's a GCF though, because 18 does technically work, 18 and 5, but I don't want to factor out an 18 here because that's not a perfect square. So let's go ahead and see what happens when I take a 9 out. You can actually show that division of a 9 if that helps. 18x divided by 9 is 2x. 90 divided by 9 is 10. So again, as you can see, this is not the greatest common factor that we factored out, but we only did that 9 because it was a perfect square. So this 2x plus 10, technically you could take a 2 out, but I don't want to because I just want to keep it again with just dealing with that perfect square. So then at this point, if you want to write them separately, you can, or you can go right to the final answer, which is 3 root 2x plus 10. That is as far as you can simplify this. All right, on to number 6, same idea, but it's 80 and 32. So again, if you're having trouble figuring out the factors of these, 80 is definitely a larger number, but maybe start with 32 because 32 doesn't have as many factors. 1 and 32, 2 and 16, 4 and 8. I think, is that it? Maybe. Here we can just look at it real quick. 32 divided by x, and just look at the positives. Yep, that might be all of them. Yep. All right, yeah. So if those are the ones, if I look through them, only I see two perfect squares, a 4 and a 16, but I want the largest one. You want to say, does 16 go into 80? So if you're not sure, just go ahead and do 80 divided by 16, and yes, it is a nice number. So that means one of the factors of 80 is 16. That means I can factor it out of both. Or you could go ahead and find all the factors of 80 if you'd rather do that. But go ahead and take 16, divide both terms by 16, see what's left over. 80 divided by 16, like I just did here, was 5. So this is 5y. 32 divided by 16 is 2. So we get 5y plus 2 inside. Then again, the square root of 16 is 4, and then you have square root of 5y plus 2. I didn't show kind of separating them. If you want to separate the radicals first, you can, like we did here. I just wanted to save time and get to the answer that way. All right, if you do have any questions on these, we can go over them Wednesday or in the afternoons. Just make sure you come and get some extra help. So next one, we are multiplying. Whenever we multiply, we're using the distributive property here. So we're just multiplying the inside of the radicals to everything inside, and then don't forget to simplify. So 2 times 6 would be 12, and then 8 times 2 is 16. Well, 12 can be simplified further because there's a perfect square sitting inside there. It is 4, square root of 4, square root of 3. That would be 2 root 3. And 16, the perfect square for 16 is 4. So it is just a perfect square. So if you wanted to kind of rewrite it like this, you could. But really, the square root of 16 is 4, and then the square root of 12 has to be rewritten as 2 root 3. You could switch the order here, so you can always write it as 4 plus 2 root 3. That's fine. It is up to you. All right, let's try the same thing for number 8. This one would be square root of 9. 3 times 3 is 9, and 3 times 2 is 6. So square root of 9 is 3, and 6 doesn't even need to be simplified. So this one's even easier. We're just done. Just 3 plus square root 6. All right, on to numbers 9 and 10 are the same, where when I see a denominator with a radical in it, I need to multiply by whatever that denominator is. So square root of 5, and make sure you do it to top and bottom, because that's how we make this a 1. Technically, we're not multiplying by a number, essentially, just 1. And you're allowed to do that in math. So the numerator becomes square root of 15, because 3 times 5 is 15. The denominator would be square root of 25, which we know is really just 5. So the final answer here is square root of 15 divided by 5. And that's it. That's how we can simplify those radicals. The last one here, or the second one like this, same thing. Multiply by 7, square root of 7 on top and bottom. Always do whatever the denominator is, not the numerator. So this comes out to square root of 63 and divided by square root of 49. Now, instead of writing square root of 63, maybe you noticed that the square root of 9 is a perfect square already, and that's just 3 root 7. So you could have just immediately gone to 3 root 7 if you wanted to. Like if I wanted to kind of think of that as a 3, and then I wouldn't have to write it as 63, I would have already simplified it. But if you want to simplify 63 now, it is the same thing as square root of 9 and square root of 7, which does get to 3 root 7. Okay, so it's up to you if you kind of take that step or not. But the denominator now is 7, and that's as far as I can simplify it. So you should simplify both top and bottom if needed. Definitely the bottom because you need to get rid of the radical, but the top sometimes has to be simplified too. Now the last two are those conjugate questions that we saw in our notes. So remember, when you do a conjugate, you take the opposite sign. Same exact square root, but opposite sign. So we have square root of 6 minus the square root of 3 on top and bottom. And so this comes out to, if I distribute it, 5 root 6 minus 5 root 3 on the numerator. The denominator, I want to do FOIL, which basically is going to make it so that my outer and inner terms, the inside here and the outer, will cancel. But if you do need to show all of the steps to get there, go for it. square root of 6 times square root of 6 is my first term, which I could have written just square root of 36. Outer is negative square root of 3 times the square root of 6, plus inner is square root of 3 times square root of 6, and last, square root of 3 times a negative square root of 3. So I'm just going to put the minus kind of in front of it. So we start simplifying. I can cross off these opposite terms, the ones with the negative and the positive, square root of 3, square root of 6. The numerator is still the same. The denominator, though, is the square root of 36 minus the square root of 9. Right? And the square root of 36 is really 6, and the square root of 9 is 3. So if you want to kind of just, without writing the whole thing out again, just kind of simplify those. 6 minus 3 is 3. So the final answer is 5 root 6 minus 5 root 3 divided by 3. Okay, and then the last one here, same idea. I am multiplying by the, again, the conjugate of it, which is square root of 7 plus the square root of 6 on top and bottom. So this one you distribute again on top, and then you do FOIL on the bottom. So if we get here 7 root 7 plus 7 root 6, the denominator would be square root of 7, square root of 7, which again you could just write as square root of 49. And then we have outer terms is square root of 7 and 6, square root, and then inner is negative square root of 6 times square root of 7. And finally, the last term is square root of negative square root of 6 times square root of 6. Now these, I didn't write them in the same order, but they are the same thing. So you can still cross those off because they're opposites. You can always change the order there. And final part here, keep the numerator the same, but the denominator is square root of 49 minus square root of 36. And those two, if I subtract them, is 7 minus 6, which is really just 1. So up to you if you want to show, all your steps like that, but I'll go ahead and write down just the answer. Final answer, I don't need to put anything in the denominator because it's just 1, right? So this is the final answer. All right, so if you have any questions on these, please make sure you come in the afternoon for some extra help.